Hi everyone, welcome to talk session. In this session we will learn how to design DFA to accept all strings having odd number of edges. In the last session we have seen for even number of edges. Let's start. First identify the condition. Here condition is odd number of edges, means number of edges should be 1. For example single A. Number of edges should be 3. I can say 3 edges, or I can say 5 number of edges. So these are the valid string as per the condition given in the question, and these become the part of the minimum length string. What about B's? There is no condition given on the B. For example, if odd number of A means what? Single A. This is odd number of A. After this, if any B is coming, check how many A's are here? 1. We want odd number of A's, so it's a valid string. If I write 2 B's after this B, if I write 2 B's after this A, how many A's here? Only 1. It's valid string, odd number of A's. So if I write 1B, 2B or 3B after this A, that is not going to matter. The string is still valid, as condition is given on the number of A's and not on B's. So let's start designing DFA for this question. As we know, DFA consists of multiple states and state represented by the circle. So Q0 is our starting state. As minimum length string does not contain epsilon, so starting state will not be final state. First minimum length string is A. A should get accepted. It means what? Transition of A from Q0 should reach out to final state. Then only we can say A is get accepted. So this Q1 should be a final state. So A is get accepted. Next valid string is AAA. AAA should get accepted. So write down this AAA in this way. Automata starts with the state Q0. So A is read by the Q0. Automata is in the state Q1. This A will be read by the state Q1. And we need to find transition for this A from state Q1. But transition from Q1 for this A should not go to final state, because there is one more A. As we know, AAA, this is the valid string and not only 2 A's. So transition from Q1 for symbol A should reach to some other state, and from that some other state, transition of this A should go to the final state. That is, as I mentioned, Q1 reading A, the transition should go to some other state, and that other state should read this A and go to the final state. So in this existing states, which one is the state which is reading this A and going to final? It's a Q0. Then that some other state is nothing but the Q0. It means what? Transition from Q1 for this A will go to the Q0 for the symbol A. That is, transition from Q1 for symbol A will go to the Q0, and the last A, third A, will be read by the Q0 and automata will go to the final state Q1. Let's verify. As our string is AAA, automata starts with the state Q0, Q0 reading the first A, Q0 reading the first A, going to state Q1, Q1 reading the second A, Q1 reading the second A, going to state Q0, write down here Q0, Q0 reading the third A, Q0 reading the third A, going to state Q1. String is completed. Where is the automata? Automata is in the state Q1. Q1 is our final state. It means what? AAA is accepted. Similarly, you can check for the 5 A's. Automata starts with the starting state Q0. How many A's are there? 5 A's. So let's check whether these 5 A's are accepted or not. First A, automata is in the state Q1. Second A, automata is in the state Q0. Third A, automata is in the state Q1. Fourth A, automata is in the state Q0. Fifth A, automata is in the state Q1. Fifth A done, automata is in the state Q1. It means it's the final state. String is accepted. Now, is this final solution? No, because we want to design deterministic finite automata. Deterministic means what? From each state there must be only one transition for symbol A and for symbol B. From Q0 transition for A is there, from Q1 transition for A is there, but from both the state transition for B is missing. Now I want to find transition for B from the state Q0. Now to make Q0 as a deterministic, we need to find out transition for B from the state Q0. For this I will tell you one simple trick. Initially you may observe it as a lengthy one, but once you practice in subsequent videos you will find it easy one. For which symbol I am looking transition? B. From which state? Q0. First question, how to reach to Q0 from starting state? Q0 itself is the starting state, so okay. Second question, how to reach to final state from Q0? From Q0 to reach to final state, I need to read the symbol A. Write down it. Now ask yourself, is this valid string BA? Yes, number of A is 1, 1 is odd, so this is valid string. Q0 is looking for only one B or multiple B's can come. Check. Before this A, if two B's are coming, is this valid string? Yes, still number of A is 1, so BBA is a valid string. If before this A, if triple B is coming, number of A's are still 1, so this is also valid string. Also before this A, if no B is coming, means what? Epsilon. That is also fine because here still number of A is 1 and it's odd. What I mean to say here, Q0 is looking for transition for 1B, 2B, 3 or 4 or multiple B's. As well, Q0 is looking for 0 number of B's. It means what? Q0 is looking for 0 number of B's or multiple number of B's. That is 0 or many B's. Q0 is looking transition for 0 or many B's. So as I mentioned in my previous videos, whenever in TOC, if you face the scenario of 0 or many, you have to give self loop to that particular state. Here it is a Q0. For which symbol? Symbol is B because 0 or many B's. So write down here B. Similarly, I want to make Q1 as a deterministic. For that, I need to find out transition for B from the state Q1. How we can find it out? You can apply the same technique here. So write down the symbol B for which you are looking transition from the state Q1. Ask yourself first question, how to reach to Q1 from the starting state? So Q0 is starting state, how to reach to Q1? By reading A. So starting state to Q1 by reading A. How to reach to final state from Q1? In this question, Q1 itself is a final, so nothing will be here. Then check whether this AB is a valid string. Yes, number of A is 1, 1 is odd, so it's a valid string. Then Q1 is looking for single B or multiple B's are also allowed. This A is as it is, ABB. Is this valid string? Yes, number of A is still odd, so this is a valid string. If triple B is coming, is this valid? A is as it is, yes, A triple B, number of A's are odd, so it's a valid string. If no B is coming, only A is coming and B will be 0, that is epsilon. Epsilon contain no B's. Is this valid string? Yes, number of A is 1, so odd number of A's. It means what? Q1 is looking transition for 1B or 2 or 3 or 0 number of B's. It means what? Q1 is looking transition for 0 or many B's. Hence, as there is a 0 or many, you can give the self loop at the state Q1. For which symbol? For symbol B. In this way, you can make Q1 deterministic. Now, this is the final answer because from Q0 transition for A as well as for B, and same from Q1 transition for A as well as for B. If you want to verify any other string where there is an odd number of A's, you can verify it. Similarly, you can design DFA as a practice for odd number of B's. In the next session, we will see designing DFA for even number of A's and even number of B's. Thank you for watching.